All right. Hello, I'm JP. I'm a data scientist, and have been very excited to participate in this hackathon. I've learned a lot building this thing. So, welcome. I built humaid, or humanitarian aid app, which will help us organize and communicate and take action on humanitarian efforts, especially when it comes to natural disasters or different types of responses that humanitarian community needs to make. This is a challenging problem because there are many actors involved, from local communities, local authorities, NGOs, and a bunch of different players that need to act promptly on the data they have at hand. But unfortunately, this data is usually not available when they need it. So even though there has been a lot of literature and learnings and documented cases, in practice, all this knowledge is very difficult to access when people need it the most. So if you look at the recent floods of the past few years, like big issues in Brazil or Spain, those are not the only places. We've had in different parts of the world a lot of crises, especially around floods. So I wanted to see what was the landscape or the whole space of humanitarian aid related to floods in Colombia, and I realized that we have like cycles from La Nina or other natural phenomena that are challenging and well documented, but sometimes this information is very scattered in different places and difficult to access or to take action on this knowledge that we already have as in different communities. So, the United Nations, the Red Cross, different organizations, and even the local leaders working on protecting their communities, they know what they need to do, but it's very difficult to access this data. So it's not only a technical problem, but mostly a communication and social organization problem, the way I see it. And a lot of that is because communicating the type of technical data around floods and humanitarian efforts is very difficult and full of jargon. And sometimes people just don't know what to do. Like if they get, I don't know, this many millimeters of rain, what does that mean? So it's very difficult to actually do something with this data. And so sometimes it's just too late when they find out and they don't know what to do at those times. So that's why we are proposing this system, which is basically a way to leverage all the knowledge that's already encoded in different platforms, dashboards, documents, etc. But it's not actionable very easily. So I made this drawing. Basically, this is Colombia right here. Took interest in two specific places, one closer to the Caribbean and one in the Amazon, because there have been different floods historically in Colombia. So what if we could get an alert system that tells the communities, the local communities, about different risks, but most importantly, give them tools or resources to act on this information. So what happens today is that even though there are many actors working in this space, usually the alert systems are disconnected from what's happening on the field. So they may have protocols and resources and different tools, but they don't actionate them easily because the alert system is disconnected from what's actually happening on the ground. So it takes, I don't know, weeks or months to get a report that then they get to do some protocols on the ground or implement some protocols on the ground. But then, this could happen in days or so usually these alerts are not very actionable. So what if we had a way to send alerts and then have local networks of different local devices with local knowledge encoded that allow local communities to work more efficiently under the stress of the different events like a flooding. So yeah, we want to send alerts and basically make this information actionable, but also have a way for local communities to understand what's happening, the history of their local community, which is encoded in many documents, government databases, and different places, in a way that they can retrieve this knowledge in their natural language. So without them, knowing very specific jargon or many specific terms, but rather using very localized information that they can access their knowledge and even get recommendations and suggestions that are highly local and relevant for their context. So now looks better with the help of ChatGPT. And basically what we built was this. I trained LFM 2.5 vision language model to identify floods in before and after pictures. I took the history of different flooding incidents in Colombia in these two regions, in the Amazon and La Mojana is the name, close to the Caribbean. Then I also tested the system and tried to make it work locally in Olama, so that I could also incorporate other solutions like a rack system based on embeddings that work locally via the nomic embeddings, which is an open source algorithm. And so now we have a local way to organize knowledge from multiple places. I used tools like Kreuzberg, which is a command line tool to convert documents into Markdown. So I organized a bunch of different documents and created a knowledge base with question and answer pairs, so that we could have a chatbot interface that's personalized to the context of the specific local community. So the type of answers will vary depending on who's asking the question. So it could be an NGO, or it could be a local leader, or it could be the local government. And so they will get different answers because the knowledge is relevant for them depending on their roles, but also depending on the time frame where they ask the question. So if they ask pre-event, there's different than if they ask specific questions during the event of a flood, for instance. And then we built different interfaces so that we could access all this knowledge from the algorithms we trained into a desktop app that could be relevant for, say, La Mojana in the Caribbean, or Android app that will be relevant for the Amazon. The reason for this is that I had the opportunity to work with these communities, and I built a tool for rural schools where they will have access to their local cultural heritage inside laptops in rural schools. And in this La Mojana in the Caribbean, it's tricky because they need to go by car or by rafts for a couple of days even to move between municipalities. But if you go to the Amazon, it's even worse. They sometimes have to go very up in the trees to get a signal on their phones, or even they even have to travel for days and days in rivers so they can get the information they need. So one way to tackle these issues of humanitarian response that's prompt and useful was with this architecture. So, okay, demo time. This is what I built. The website, desktop app, an Android app, and all goes into the inference system, which is dual for images, satellite images for detecting risk indicators of floods, and a knowledge-based system that pulls information from multiple contexts and knowledge and resources that are available from the government, from the United Nations, from the Red Cross, etc., with recommendations for specific timeframes and actions, and also an alert system that will give prompt alerts basically for people working in these scenarios. Okay, so let's see. This is the app. You can go to humaid that app. Maybe it's a difficult name to pronounce, but well, anyway, so yeah, the knowledge between respondents and local communities, and the network access is a challenge. And so I wanted to bring back like all technologies that they had in this region for making these canals, which is it's not available anymore, but perhaps with better technologies with like AI and better more prompt answers, we can give them what they need. So our landing page, and then if we go to the demo tab, we have two systems. One is to understand like the different phenomena and crisis plans and protocols and different types of resources. But during a crisis, it's very difficult to know what's happening. So we can also use these and ask different questions about emergencies, and then this will go in and pull all the data from the knowledge base, filtered by the different types of roles and regions where we're working, like the Amazon or the Caribbean in La Mojana, in the wetlands. So who do I call if an emergency is starting? Then I can get specific resources and questions and suggestions of what to do at different phases. So maybe if I am during preparation, or the recovery, it may be different, and maybe the role will change. So yeah, I don't know. And then it will pull relevant information for this type of context. And then, so you see, I ask question what to do, and then post-recovery, I get different types of answers that are relevant, like debris removal, for instance. So these are type of suggestions that we personalize depending on the profiles of the users and even the regions they are working with. Okay, so that's about the knowledge base, and then which we train an Olama algorithm with a DuckDB database and local embeddings running Olama as well, and open source embedding algorithms. And then we have a way to test the algorithm from before and after for floods. Then we can also see what happened before in other cases, and then we can also send alerts to the different systems. Okay, so now we're back here. Let's say this desktop app is on the site in the Caribbean, and then they also have information about the documents and all the things. If you see here, I hit here, and then an alert was sent, and then we get different flood alerts right here, also on the documents. We can have this in different languages, of course. And then we will get several localized answers depending on the different context. So in the alert system, so this is a simulation. So the satellite will send an information like we did just here. And then on the web app, on the desktop app that's on the site, we will get different types of alerts, as you see here. Then this is like an image generated directly from the payload on the satellite, and then this is the alerts that we will get. So we can also see different regions, and then we get different types of alerts directly from the system. And then if we go to the Android app, let me restart this here. Then we can see also the different types of resources that will be available offline, which includes also the same knowledge base where people can ask questions right here, or the type of documents that they can also search and look for, contact information or whatever, and then they will get also the different types of alerts that arrive from the system. Okay, well, I guess this is it. It's a quick overview of what's going on. I'll try to push some additional fixes in the next couple of hours, and I hope you enjoyed this project. I really liked building this. Well, thanks so much.